circle. Would it work for you to tell me when I have like 10 and 5 left? 10 minutes and 5 minutes?
Oh, okay.
Yeah.
I was just going to check this when.
Yeah. So you decide when you want it. I'm good at condensing.
Yeah, you have to.
It's easy to go on and on, but when I find out I'm behind, I can go very rapidly at the end.
It's 11:30, but you haven't. I mean, we're not on time anyway.
Okay. So you decide what you need for the schedule.
So you have like 45 minutes.
Yeah. And I'm glad to meet myself. Yeah.
Okay, good morning again, everyone. Welcome to the second keynote presentation. I'm honored to present Professor Douglas Vakoch. He's Professor Emeritus in the Department of Clinical Psychology at California Institute of Integral Studies from 2017 onwards. As a leading researcher in both astrobiology and clinical psychology, Professor Vakoch studies the human dimensions of global warming and environmental degradation. He is interested in the sustainability of human civilization on multi-generational timescales. His expertise includes space exploration, the social impacts of science, and environmental threats to humanity's long-term survival. He is president of METI International, a San Francisco-based research organization whose namesake activity is messaging extraterrestrial intelligence, sending powerful intentional radio signals to nearby stars to elicit a response from possible technological civilizations. Prior to founding METI for 16 years, Dr. Vakoch worked as the SETI Institute, at the SETI Institute, where he was director of interstellar message composition. So METI is messaging extraterrestrial intelligence. SETI is interstellar message, right?
Yeah, SETI search for extraterrestrials. METI is the more active messaging, sending messages to them. Yeah.
He is an elected member of the International Institute for Space Law, and he serves as the chair of the International Academy of Astronautics, which is a study group on active SETI investigations, scientific, technical, societal, and legal dimensions. He's also director of Green Psychotherapy, a private practice that helps clients with eco-anxiety. This is, of course, the most very interesting, but for us environmental humanists, Dr. Vakoch is also very important because he's the general editor of Lexington Books' Ecocritical Theory and Practice series, He is also the general editor of Critical Plant Studies and Environment and Nature. These are the book series he leads at Lexington Books. His work has been featured in New York Times, in Nature, Science, and Der Spiegel. And he has been interviewed on radio and television shows on BBC, NPR, ABC, the Science Channel, the Discovery Channel, and there are many numerous others. He has also edited numerous books, actually over 20 books himself, including Communication with Extraterrestrial Intelligence. This is from 2011. Feminist Eco-Criticism, 2012. Archaeology, Anthropology, and Interstellar Communication, 2014. Ecopsychology, Phenomenology, and the Environment, 2014. The Drake Equation, 2015. Transecology, Transgender Perspectives on Environment and Nature, 2020. Ecofeminist Science Fiction, 2021. Transgender India, 2022, this year actually. And the Routledge Handbook of Ecofeminism and Literature that came out this year, 2020. His keynote address today is entitled Communicating with the Other, Semiotic Perspectives on Messaging Extraterrestrial Intelligence. Dr. Vakoch, welcome.
Thank you very much, Serpil, for the gracious invitation and introduction. Thanks to Sinan for all that you've done to coordinate this with Serpil. I'm delighted to be here and to talk with you about the ultimate alien other, extraterrestrial intelligence. And I do so from what in one way might be seen as a pragmatic perspective. I'm going to talk about what we would actually need to do to make contact. So this isn't just a discussion of the images that we have or the reflections that we've had. I'm going to narrow my focus to look at those civilizations we could actually make contact with. And I think that'll help limit what we talk about. But ultimately, my end goal is to get your help in figuring out how we could actually make contact with extraterrestrials out there. So I'll go through a number of topics, start with a bit about the history of ideas about life beyond Earth, and then think about what it is that we would have to have in common to make contact at all. And then also look at some of the ways that we could establish a common language. Some of the challenges that we have, I think one of the problems is that most of the people in this field have been scientists. So that comes with some assumptions about science that are probably not warranted. And we have some ideas, I'll touch on some ideas from semiotics that might help us deal with beings who perceive the world in radically different ways. But we also need to think about what we can assume about the nature of those civilizations. So are they younger than we are? Are they older than we are? And what does that imply about their nature? Are they benevolent? Are they evil? Do we have anything to be afraid of? Ultimately, though, by the end of the talk, my hope is, it's an ambitious goal, but I fully expect to achieve it. I expect that within this room today, we will identify some sort of alien other that will help us lead to first contact. So let's jump in. The idea that we're not alone in the universe has a long history. Say in the ancient Greece, 5th century BCE, Metrodorus said to think of the Earth as the only populated world in infinite space is as absurd as to think that if you sow an entire field with millet, only one grain will grow. So not very likely. And a lot of speculation through the Middle Ages, but I want to fast forward to the 19th century, early 19th century, when some pretty serious folks were thinking about ways that we might actually make contact with intelligent beings. And let me tell you, I'm limiting my discussion today to the assumption that the aliens have not actually arrived. So they're not here on Earth. So it's actually a more difficult process that we have to make contact with them on some other celestial body. And in the 1820s, that obvious celestial body was the moon, and no less of a genius than Carl Friedrich Gauss suggested, if you want to communicate with intelligent beings who live on the moon, go to the forests of Siberia, plant some wheat fields carved out of the forest in the shape of the Pythagorean theorem, and it would let the aliens know that we're savvy about geometry here on Earth. A little bit later, another scientist at the time, Joseph von Littrow, Austrian physicist, said, you know, you can do the same thing when the dark side of the Earth is facing the moon. If you go to the Sahara Desert, carve a huge canal, tens of kilometers in diameter in the Sahara, fill it with kerosene and light it. And they'll know something about that. We appreciate the elegance of the circle. And so these were some ideas of how to communicate when we assumed that life could be very close. In the 1820s, scientists didn't know that there was no atmosphere on the moon, so it seemed plausible it could be inhabited. But as we learn more about the moon, we realize we have to look further out to find plausible environments for life. One possibility through the 19th century into the early 20th century was Mars. In fact, some thought that these lines on the surface of Mars represented canals to carry water around the surface of the red planet. And the problem, of course, is if we want to signal Mars, it's so much further away than the moon that we can't just carve something on the face of the Earth, hope they'll see it. We have to send some sort of an encoded message. In 1869, the French polymath Charles Cros suggested, well, you could do that by just sending a series of pulses. He suggested flashing huge lights, mirrors that would signal either Venus or Mars. And in his case, it was just a string of numbers. And the hope is that the civilization would be able to reconstruct those into a two-dimensional grid, kind of like old school television. And there are other ways of doing it. Similar ideas were proposed in which you use dots or dashes. And in fact, this same idea independently evolved for the messages we have sent out, now thinking of messages of two slightly different frequencies, pulses of two slightly different frequencies. So these are ways that you can send a signal, but they need to be reconstructed, which of course makes it more difficult and more ambiguity arises. But as we learn more about Mars, as the 20th century progressed, we became less optimistic finding intelligent life there. And so we have to move out. So the good news is, starting about 30 years ago, we began discovering exoplanets, planets around other stars. And now when we go out and look at the stars, we know that virtually all of those stars are orbited by planets. So there's an incredible amount of real estate out there that could be home to intelligent life. Is it really there? That's what we're trying to determine. And the first search for extraterrestrial intelligence was conducted on this telescope, Green Bank, West Virginia, 1961, looking for signals from two sun-like stars near Earth. And it continues today. So over the last 60 years, this has progressively gotten more sophisticated. Now there's a multinational search of signals from over 1 million stars and another 100 galaxies. So this is the best bet we have right now of finding life beyond Earth. SETI, we could find extraterrestrials tonight, as early as tonight, with this approach. So suppose we do. Suppose we get a signal, or suppose we send a signal of ours. What is it that we need to assume about that other civilization in order to make contact? Because again, there may be these wonderfully intelligent whales in the oceans of a distant exoplanet, but if they can't build a radio transmitter, we're never going to know about them. So what is it that making contact in the first place gives us in terms of knowledge of the extraterrestrial? What can we assume if we assume that we make contact? So again, this is a constraint on the nature of the civilizations that we can encounter. And one possibility that's been promoted and used as a basis of interstellar messages is math and science. And so the idea is if you can build a radio receiver like the one in Green Bank, you're probably a good engineer, and you're going to be a lousy engineer if you don't know some basic math like 2 + 2 = 4, or some basic principles of physics. If you're an astronomer studying the universe, you probably know some basic chemical principles. And so then the idea is, what's the format you put those in so that they could be recognized by mathematicians and scientists on other planets? So you might send simply a series of pulses, and it could start with something as simple as 1, 2, 3, 4, 5. But then you could send a bit more complex series, 1, 4, 9, 16, 25, and that might provide a hint to the format, because those numbers are just 1, 2, 3, 4, and 5, but they're squared. And so you could use an approach like this to build up a way of sending little pictures or diagrams. And so imagine we sent pulses of 3 different radio frequencies, and we're representing them here as either black or white or red. Well, you could use this as a frame for counting. Just whenever you want to add another number, 0 in the first frame, 1 in the second, 2 in the third, 3 in the fourth, 4 in the fifth, 5. Of course, the problem with this kind of a numbering system is the maximum number you can get is 25. If you use a binary code, I won't go into the details of it here, but the first few frames actually look pretty similar, but the binary code, every additional digit is twice as big as the first. So in the same space, you can count up to 33 million. So you can get a big number in a small space like this. And so one possibility, if we want to communicate some scientific concepts, is to build up these rudimentary pictures and link them together. And the hope is that there are chemists on other worlds who say, oh, this looks like our periodic table of elements, because there's a simple counting, in this case, the number of protons in the nucleus of an atom, and the way they're arranged corresponds to some of their chemical properties. So this is an example of the typical approach we take to creating a message that we hope an extraterrestrial would understand. And in fact, even talking about something as seemingly lifeless as chemistry, I would argue, becomes a foundation, as we'll come to toward the end of my talk, for even describing something distinctive about our species at this point in our history, specifically something that defines us in the Anthropocene. And I'll give you a preview of our next transmission that's happening in October of this year. This is the first scientific and humanistic conference that I'm presenting this at. The goal is actually to start getting input from the broader academic community. And so I'll be hoping to get that from you in the break and discussions afterwards. But even starting with something as seemingly lifeless in chemistry, we can say something important about humanity right now. But of course, this all presupposes that science is universal, doesn't it? And is that really the case? You know, one of the metaphors that I think is useful for thinking of scientific progress, at least as it's often been thought of in the SETI community, it's kind of like climbing a mountain. And so here's where we are. We've climbed a certain distance, but maybe there are other civilizations who've been at this a lot more, and so their science is more sophisticated. If a comprehensive understanding of things is reaching the mountaintop, then they have gone further up than we have. And so if they want to send us a message, all they need to do is kind of turn around and look where they had come from, and they'll send us a message that we'll clearly understand. There's only one problem with this, because even if science is getting a progressively better understanding of the universe, what happens if they're actually climbing up another side of the mountain? After all, they live in a different environment. They have a different history. They have a different culture. The philosopher of science, Nicholas Rescher, said, you know, if we meet some intelligent beings who are aquatic, they're probably going to have a very sophisticated hydrodynamics, because they're going to need that kind of knowledge of being in a water environment. And it becomes all the more difficult, of course, if the better analogy is not that we're both trying to climb the same mountain in doing our science, but from different sides, but that their reality is so different, their environment, their history is so different. It's like climbing up a different mountain in the mountain range. Well, if this is how science works, then what hope is there for using science as a common language for communicating with extraterrestrials? And I think the problem is compounded when we realize that maybe the aliens won't even sense the world in the same way that we do. This is a message that was sent on a couple of NASA Pioneer spacecraft in 1972, a metal plaque with greetings from Earth. But the real situation is when we're greeting the aliens, we don't know what the aliens on the other side of the door are like. Are they going to be like chimpanzees or dolphins or hyenas or butterflies or more like worms of some sort? But the problem is if we send a message out, it has to be a multi-purpose message. And in fact, I think that's one of the arguments for us sending something out, just so they can get a sense of what we're like. They know what kind of creature we are in their taxonomy, and it might give them a better idea of what to send to us that would make sense. So I'm personally not a subscriber that there's one universal language, and they'll send us the Encyclopedia Galactica, and it'll be clearly intelligible to us. My concern is that they may not be able to think at the rudimentary level that we do. But if we can give them a sense of our level, they'll say, a class K17 civilization. They seem fixated on binary digits. Send them some of that stuff, see if they like it. But maybe we can draw on insights from semiotics to think about how to send messages that aren't quite so tied to our specific senses. And let me go back to a message that was created. This was in the months following the first transmission from Green Bank, West Virginia. There was a first SETI conference. Frank Drake was the astronomer who did the transmission project, who held the conference. And afterwards, he sent a piece of paper with 551 ones and zeros to all the participants and asked if they could decode it. He said, imagine this is from a hypothetical alien civilization. What does it all mean? Well, when properly reconfigured, this is the picture that you get. And I just want to focus in on a couple of parts of this to distinguish between the types of information that we can send and use some terms that we are familiar with, but I want to use them in a particular semiotic sense. So icons we think of as images of objects. So that squat figure toward the bottom is supposed to be the alien that sent the message. So it's an icon. And in semiotic terms, there's a physical resemblance between the sign, the image that we're sending in this case, and the thing it stands for, as opposed to a symbol in which it's a purely arbitrary connection between the sign and what it stands for. And so those four little squares underneath the squat figure are its name. It's just an arbitrary 4 bits that are to be a name. And so we would expect icons to be more recognizable. Symbols, they wouldn't be because it's arbitrary. So how might, well, first of all, we've used this distinction in some of the past messages we've sent. In addition to the squat figure, in the upper right-hand corner, you also see icons for atomic structure, the carbon atom surrounded by 6 electrons, oxygen surrounded by 8 electrons, a diagram of the solar system on the left-hand side. And we've also seen a similar combination of icons and symbols in messages we sent out on the Voyager spacecraft, a couple of NASA spacecraft from 1977, that included those same sort of Bohr models of the atom on the left-hand side, and then linking them with particular symbols for the numbers, for the names for chemical elements, C for carbon, N for nitrogen, etc. And We can get increasingly complex, in this case showing DNA. But the big problem, even when we send icons in which there's a physical resemblance between the sign that we're sending and what it stands for, it is a resemblance as understood, as interpreted by the recipient. And so if they perceive the world in a very different way, or if they have a different set of conventions, I mean, there's a natural link, but there's still interpretation involved. So what can we do that helps our icons be interpretable by a wider range of possible intelligence? And so one possibility is, you know, if the aliens are really out there, maybe they can see. I mean, vision has evolved 40 times independently here on Earth. Maybe it'll evolve on a lot of planets too. And so what we could do is describe something, you know, clearly a physical object like the human body. Although again, we see that becomes problematic because even here on Earth, there are different ways of representing this universal human body. For those who aren't trained in Maori conventions, this looks like some beautiful geometrical shape. It's actually a clear image of the human body if you know the conventions of this icon. Among the Abalam of Papua New Guinea, this is obviously a human being with the arms and the legs and those four little circles being the eyes, and also the stars, because the stars are the eyes of the ancestors looking down on us. So even in depicting something like the human body, here on Earth with other humans who have the same bodies, we have radically different ways of representing that. So this whole idea of sending icons is looking a little bit limited. Well, maybe we can teach them how we see. So on that Voyager recording, there was some attempt to show that, you know, when we have these two-dimensional representations of three-dimensional objects, there could be things in the foreground that are actually a lot bigger on the image, but the same size as the object in the background. So these hunters are the same height as the antelope is long, and the antelope is in the background. And we can also build in some ways of confirming that they got the message right. And the beauty of sending a spacecraft is you've got this concrete object you can compare it to. So there's an encoding of messages, a bunch of bits, and if they're properly reconfigured, you get a confirmation, because in the metal container that holds the record, the first image that shows is one of a circle. And again, it's kind of a nice echoing of von Littrow's idea of, you know, we want to let them know that we sure are savvy about pi or geometrical concepts. But again, what if you use a different sense? What if you don't privilege vision? And I think this is where some ideas from zoosemiotics can be useful. There is a very dangerous wasp called Dolichovespula arenaria. And there is a fly that uses that wasp, mimics that wasp, and thus avoids predation. And it doesn't do it because it has a coloration that's similar to that wasp. In fact, it is similar to the wasp because it beats its wings at the same frequency that the wasp beats its wings. So when we think of icons, we think of a skull and crossbones, a picture of skull and crossbones standing for poison, because there's some link between the image and what it stands for. In this case, it's an auditory icon, so that there can be an icon, but it's not bound to just a visual sense. And so how could we do something like this in the message itself? So, because again, when we're sending radio signals, we don't see or hear radio signals. We have to transform them into sounds or images that we can perceive. Radio signals are going through our body right now. We can't directly perceive those, but can we use those as icons to communicate with the extraterrestrials that are picking up those radio signals directly? I think so. And in fact, that was the foundation for a message we sent a few years ago where we overturned this common assumption of SETI saying, you know, vision is going to be universal. It happens so often here on Earth. Well, it's great here on Earth because we have an atmosphere that lets light through. But if you've evolved intelligence on a world with a murky atmosphere, vision isn't going to be very useful. How would we send a message that would draw on some of these notions of iconicity that might be intelligible even by blind aliens? And so this was a message we transmitted from a transmitter in Norway called IceCat. It's a little town called Tromsø. If anyone's heard of it, it's probably because it's a wonderful tourist site for seeing the northern lights, Aurora Borealis. Well, it's also a great place for scientists to be stationed who want to understand Aurora Borealis. So they send radio signals and some small fraction of them bounce back, and that lets them tell about the composition and the structure of the upper ionosphere. But most of those signals go off into space. And so we use that to transmit to a nearby star, Luyten star, 12 light years away. On a galactic scale, that's pretty close. It takes 24 years for a message to go there, reply to come back. And the core of our message was inspired by Gauss, the idea of a Pythagorean theorem. And so we sent a series of numbers. You know, we can do this counting thing. In this case, the way we sent it was not just the pulses themselves, but we would send groups. We'd use a byte, a string of 8 ones and zeros, 2 different frequencies. And that became our way of communicating numbers. But then we also communicated some symbols. So things that aren't just numbers, but for example, the notion of time or the notion of a clock. So we would have a number and then we'd have this symbol for clock, and then the numbers would advance and the clock would appear. And the hope is that the extraterrestrials would be able to map that on and see the passing of time reflected in the clock. And then we went back 24 hours later and repeated the whole thing, and the clock keeps ticking. 48 hours later, the clock keeps running. And so the idea was to have a link between the signal itself, cut out the intermediary of how we picture things or how we hear things, and focus on the only thing that the extraterrestrials and we really have in common, which is that radio signal. And so we have a mathematical description of what we're sending, but then we can actually point to the signal itself. So we have a mathematical description of frequency. And then we can point to the 2 frequencies that we're using, and the extraterrestrials should get a confirmation of that. We talk about time and send different durations, 1 second, 2 seconds, 3 seconds, and then the entity, the recipients, get examples of that they can link back to the more mathematical description. And of course, you know, you may be saying, you know, Doug, you're saying this is not visual, but this is the Pythagorean theorem, so that's triangles. Well, for us, sure, we always put this, we always draw pictures of this. We're very visual beings, but there's nothing about the Pythagorean theorem that has to be related to a visual sense. You can get the same concept by these numbers. 3 squared plus 4 squared equals 5 squared, 6 squared plus 12 squared equals 13 squared. So we sent a series of these, what are called Pythagorean triplets, numbers that follow this Pythagorean theorem, and kind of expanded it out a bit. But the takeaway point is that our goal was to send a message in which there was a direct link between the nature of the signals that we're sending and the concepts that we want to communicate, in an attempt to get through some of the arbitrariness of our representations. So we're communicating with beings. We don't know what their sensory modality is. We assume they have math and science. How old will they be? Will they be younger than we are? Probably not. If they're younger than we are, they don't have the technology, so we won't be able to make contact. Could they be the same age as we are? Well, we're about 100 years old in terms of interstellar communication. That's how long we have had radio to communicate at interstellar distances. So let's assume they're about as old as we are. So what are the chances in the 13 billion year history of the universe that our 100 years and their 100 years coincide? It's virtually zero. It's as likely as in the course of a long, dark night, two fireflies each flick on once, but exactly the same moment. How likely? It won't happen. So the only way we can make contact is if they've been at this much longer than we are. Now, it could be that civilizations do last 100 years. They annihilate themselves, they turn inward, they stop exploring. But if that's the case, we won't make contact. The only way we make contact on purely statistical grounds is if they're much longer lived than we are. And that has often been the argument for why we should simply be listening, because it takes more resources, it takes a longer timescale, more security that you're going to be around, so that we as the young civilization should just focus on listening and let them, the extraterrestrials, do the heavy lifting. And we can come back to that and see if there's some alternatives as well. But one of the things that you think about it, and since we don't have extraterrestrials, we have to look for analogies. If we look at analogies of when a more, not just long-lived, but we assume that if they're longer lived, they're probably going to advance at least some in technology over us. So if they're technologically more advanced than we are and we encounter them, what would that be like? Well, the history of two human civilizations, one more technologically advanced than the other, does not bode well if we use the example of European explorers coming to the New World. Did not turn out well for the indigenous people. So is that what we can expect? And so I think notions of the alien naturally pull for our sense of aliens that may be advanced and have malevolent intentions. I suspect this is an example of ecophobia. In fact, it's very comforting to think about there could be these malevolent aliens out there, and all we need to do to be safe is just don't transmit. It's very empowering. We don't really have to look at the real source of the threats that we have to life on Earth here now. But I think it's also just part of our natural projection of our desires, both positive and negative, our fears and our hopes into the cosmos. In the Middle Ages, we talked about dragons, and we have projected those dragons, Draco, into the stars. And so when we imagine aliens coming to Earth, the H.G. Wells War of the Worlds scenario readily comes to mind. But there's only one problem with this analysis. And so this has been one of the greatest challenges for METI, is not by astronomers. Astronomers who I've talked to say, well, no, it's not really a threat. We're not concerned, but the public is. So you'd better be careful what you do, because the public might get quite concerned. Personally, I think that's sort of shortchanging the intelligence of the public. I think everyone can understand the argument if we'll just step back a moment and realize that it's really already been
Hello, this is a message from the conference hall Zoom. We've lost audio.
Do you now?
I'm wondering what your thoughts are on that.
There was a commercial project by a company called Celestis back in the 1990s. They sent out some signals. Actually, they sponsored some of the best signals that were sent from a transmitter in Evpatoria in the Ukraine. And it was actually one of the transmitters that we were trying to get time on. And it turns out that in terms of access, it was probably fortunate we didn't think we would have time on it. But they, in addition to sending out messages, they had offered people a chance to send a message to the future, so a biographical statement, a picture, and 6 strands of hair. And they were going to extract the DNA and put that on a spaceship. I think they never got enough funding to actually send that out, but it was a project that fits what you're describing. And other people within the space arts community, Arthur Woods, a sculptor who has sent some of his sculpture into the microgravity environment of space, has suggested sending genetic material to other planets. There's a big debate about whether we should avoid contamination from a scientific perspective. If we go to Mars, we don't want to pollute it with microbes from Earth, because then we couldn't detect Mars. And if there's Martian life, maybe microfossil life that used to exist when water flowed on the planet's surface, we want to give it a chance. But so there are debates about this. But I think one of the challenges of something like that too is the implementation. But again, you can implement it to differing degrees of thoroughness. So you could send some DNA into space, and even if it doesn't reach a recipient, it has taken a first step. So it's consistent with what some have talked about. So far, it hasn't been actualized.
Yes, let's continue. Yes, please.
Yeah.
Hi, I hope you can hear me. Thank you very much for your talk. I'm a big fan of Kapadokya in the past. I wanted to ask you about this idea of galactic communication protocols, that there might be a set application form or methodology for, in other words, we're not getting the key code on the door right at the moment, or maybe there's some kind of Star Trek Prime Directive in space that they have prohibited themselves from contacting us in order to preserve our purity and give us a chance, like the Martian microbes. How do we therefore inhabit that kind of extremely alien conceptualization to second guess what the door code is?
Well, I think it depends how universal the door code is. So if we really imagine there is a galactic club and everyone is in communication and they are all doing the same thing, then maybe we stumble across the right approach if we try enough approaches. But maybe in fact there isn't complete communication. So my training is as a psychologist, so I think about how would I do an experiment. I would divide the stars into 2 different groups and sort of randomly target. This one I'd leave alone. Don't send anything here. This one, send a message, and see if you get, over the course of a long period of time, a different response. But again, it all depends on whether there really is coordination between them. And even this idea that, they are waiting for us to take the initiative, maybe yes, maybe no. There's always going to be an ambiguity about what silence means. It could mean that they are out there. We haven't figured out how to say abracadabra to get a response back. But what we can do, I think, is to consider alternatives that may generate a response.
You have, okay, 2 more.
Thank you very much for sharing my opinions. Recalling the film Arrival from Envhum, I was wondering, because your talk was really based on how we can be prepared to send the message. I was wondering about the other side. How can we be prepared to receive a message? Like, are we ready to decode it? Especially thinking about the fact that, like, I mean, we've been living with all the biodiversity on Earth for 1,000 years, but we still cannot understand their behavior. We still deny the language of plants. So in that respect, I was really curious about your thoughts.
Well, I think you're right about all of the ways that we are blind. And so I think that is actually a reminder of why plant studies and animal studies are important to remind us at least of non-human ways of communication and sentience and agency. I'm trying to remember the first part of your comment was, okay, can we be ready? And Arrival, I mean, The Arrival was a great movie. And I was so envious of those linguists. I mean, the aliens came to Earth and it took a few weeks, but still it was back and forth immediate. None of this, wait 100 years to see what kind of response you get. And even then it was difficult. In a sense, the challenge of understanding at all provides a natural buffer for our preparedness. I think it's likely if we do get a signal, maybe we'll know that, oh, this is an artificial signal. Even then, I mean, when pulsars were first discovered, it was thought maybe they're aliens. And so it'll take a while. We'll think, is there a natural explanation? If ultimately, we decide there's no natural explanation. I don't count on them sending us exactly the kind of message we expect and we'll be able to decode. So that gives us some time. But I think the Arrival is provides a nice metaphor as well about what the ultimate long-term impact would be. So spoiler alert for anyone who hasn't seen Arrival and you want to put your hands over your ears right now. But I mean, the idea was that this encounter with an alien actually fundamentally changed the protagonist's sense of time, that time ran differently than what she experienced as a human before. Now, I don't expect that's really what we're going to find, but I would expect that it would be something of that magnitude, something as unexpected. But of course, something that is that unexpected is also incredibly difficult to understand. So I think the biggest comfort of us being overloaded by contact with an alien is just, it's going to take us a long time to figure out what's happening. And in the meantime, we're going to project all of these images and fantasies we have, positive and negative, on the aliens.
Okay, one more. Yes. No.
Thank you, Professor Vakoch, for a very interesting speech. First, I must admit that I'm half a believer of the other, the alien other, already on Earth, living among us. Not completely believing it, but I do sort of have a sense of them existing. And plus playing with time, that they're able to travel in time back and forth. So controlling, manipulating us unawareingly. So first of all, perhaps a question would be, would you believe in such a existence on Earth? Plus, one more thing about these messages sent out to the space. You were talking about visual messages first, and then you said we have considered, okay, they may be blind. And then audio messages you've added. What if they're both blind and deaf? So I was wondering, is there a kind of communication with them in a sensual manner, in a manner of just existing as a being? So these are my questions. Thank you.
Great. For the first one, would I be open to them existing here and somehow temporally influencing? The answer is yes. And at least for me, it would always be through a generally scientific framework. So one of the principles that we use with SETI and METI is, in order to have evidence that's convincing, it needs to be replicated. It needs to be something that someone else can see, so that someone else can confirm. So if we get that kind of evidence, then that could be very compelling. I haven't seen that myself for contact scenarios here on Earth. But if I got that, then that would be compelling. Okay. So then the challenge is, so you may know that the aliens are here. You may have direct understanding and knowledge of it. The question then is, what is it that I can see that will convince me? So if I get a message, if we get a message in at one of these SETI facilities and I see it on the screen, but we didn't have the recording button on, and I know they're out there, I don't know how I can convince anyone else. So I think the question is, what is the process then to be able to share that knowledge that people who have had contact, have an understanding, can make that known to someone else? I don't have the answer to that. The second part, I know we're running over time too. Second part was about beings who do not see, who do not hear. Absolutely. So the example of the radio signal, and I was very brief about this. Our goal was to say the only thing that the aliens, we know that they're getting is they're picking up the radio signal itself. So let's talk about characteristics of that radio signal, very much as you described in more non-corporeal or I forget the term that you used, but it was something, it is not bound necessarily to any sense. Think of it as a sort of a Platonic notion of, here are some logical suppositions, some mathematical suppositions. So that was the process that we used. And, I drew the analogy to hearing, but my hope is those descriptions of what a sine wave, the radio wave that they're detecting is like, using the ideas of the Pythagorean theorem and the ratio of one side over another side, that should be understandable if you're a mathematician using any sensory modality, potentially.
Okay, I think we've run out of time. We may continue our discussions during our coffee break. And thank you once again. Before we apply for the Galactic Federation, if it even exists, we don't know, as the Earth, we should be proud to be part of the Earth community. And we together with Dr. Akula, Kapadokya University has donated 10 saplings on your behalf. Thank you very much. And you're now part of the Earth community here, and we want to present this together with
Thank you so much. Thank you so much.